So how's everything? No, it's okay. We can now progress. So I'm creating. What I'm creating first is I'm creating a row vector. So the row vector, as I told you, I would say f is equals to square bracket, say 23. Can use a comma, say 45, 45, 65, something like that. I close this. So if I not suppress, let me save this. I think it's already saved. So if I run this, I want you to watch what happens to my command. Oh, it's fine. It will display. As you have seen, to display is the value of f. But then if I enter another vector, still of the same dimension as that, say 43. So this one here, let me create it using space character, 23, 12, then say 57. Yeah, I suppress that. So if I run, you see it does not print anything, because yeah, that's what suppressing does. Terminating, putting a semicolon stops the what? Stops it from printing printing the output. So next is let's create a column vector. A column vector. Column vector. Column vector. So yeah, column vector, as I told you, you would use say 56 and then terminate using a semicolon. Whoever is annotating on our screen now, please stop it. Onesmus, I'm told it is you. 60, 67, 34, 23. Okay. So if I run this, so that you can see how my column vector looks like. Yeah, that's how it is. So that is okay. We can now progress on to the next thing. So now, what vector operations did Dr. teach yesterday? Something of dot, dot product, cross product, and so for dot, I would simply say that open. So I want to get a dot of f and g. So f comma g. Let me assign it to a variable and say w is equals to that. So I can now come and display w. Suppress R and then run this. So from A-level math, you know what? Okay, let's see. Hopefully that's the answer, right? F dot R. What does it produce? F dot G, because this is one row. These are two rows. Two rows, one column, right? So what would it produce? Something like that? Yeah? Yeah? Here? Here. This is for creating a column. You use semicolons. You terminate each column, each row using a semicolon. Because this is the first row, we terminate it. Second row, you terminate it. Third row, you terminate it. Fourth row. No, we are trying to get the dot product of f and g. 1, 2, 3, 4, 1, 2, 3, 4. Let me run it again and see. Let me check for something. So as I told you, you can always check for the help. Help dot. Let me just magnify this. Yeah, so vector, it is simply a dot into brackets a comma b. So that's how you do the dot product of a vector. So if you wanted to do cross, so let me just put a comment here as I told you. This is dot product. Oh yeah, I know why it was printing two outputs because I should have just left this as that. And now run this. Yeah, now brings the answer 575756. That's supposed to be the answer. So in case now you want to do a cross product, yeah, this answers what somebody was telling me. When do you know when to suppress and when do you know when not to suppress? Basically, as you interact with the system, you will eventually figure out when not to and when to. I can't tell you that suppress after each line because that would be wrong. So for cross, you simply type the word cross. So F, comma G, supposed to bring us 1. Okay, line in let's see, error in line 10. Cross. Let me first check. Cross.
It's just like multiplying a matrix. Remember, you have one,
Yeah.
one 4 by 1.
Yeah.
One
Oh,
by 4.
yeah. So it can. So
maybe you can.
So you can.
F and R.
Yeah, F and R. Yeah, you guys still remember the math. So multiplication of these things here. Let me see the answer. Error.
You first create another. Instead of R, create like R, right? You create another one. Where there's R, create another one.
Cross product.
Where there's R, you create another one. Maybe you create another one which resembles R.
So okay, let's see. T is equals to, say, 23, 45, 98, and then 14. So I want to get right error, but let's see, A and B must be. Let's see, error using cross line that A and B must be of length 3 in the dimension in which. Okay. So let me try reducing the length of this. Yeah, now works out. So yeah, that's the answer of the cross product of R and T. So as I told you, basically with programming, you'll have to interface with many errors to know what to want. So with Matlab is kind enough to tell you what kind of error you have. So in case you have an error, Matlab is kind enough, but Mathematica is not kind enough. You may have to spend some time practicing. But yeah, that's how you do cross and dot product in Matlab. So next we can try adding addition. Basically, the rest of the things will now remain the same. So now this is element-wise, say let me say addition. I'll use addition, then you replicate it for the rest. So assuming I have, I want to get f, I want to multiply each individual elements. Let me go back up here. I want to get 56, I add it to 23, 67 add to 45, 34 add it to 98. What I would do, I would come this side and use element-wise addition and say, let me say y is equals to t dot asterisk r. Just element-wise multiplication. You can put it fine. You can use addition. You can suppress that. Let's see. Oh yeah. Yes, this would bring us an error. So let's see if we put it to that element-wise multiplication instead, and then display y. And now here, in this case, I'm just multiplying element-wise. Let me try and magnify this. And then go back to, yeah, you can get your calc and see 56 times 23. See if it gives you 1288, 60. So this is element-wise. When you want to get an element of this and multiply it or add it, or even divide it directly to the one in the same position, the first element of a vector, multiply times the first element of another vector. That's how you do it. So you replicate the same things for division. So next we can now go to matrices. Comment this and say matrices. Okay. Let me send the slides to Bliv's laptop and then we shall continue.
What if you don't put this?
Yeah. If you don't put Bliv is asking if you don't put that asterisk there, it will be like okay, fine. You can see what it brings out. It will be a little bit similar to, yeah, sun error.
So if you just put multiplication without the dot.
Yeah. In this case here, if I put, I was trying to multiply element-wise. The first element of an array of the vector here, 56 multiplied by 23. That's what I was trying to do. By the other various products, I have now known how to do them dot and cross product. Dot product results into one block number. Cross product results into a new vector. So we can now go to matrices. So matrices is just a multidimensional vector, something like that. It has multiple rows and columns. So how you create a matrix in Matlab? Use your knowledge of creating rows and columns. So let's have 1, 2, 3. That's alright. Sorry, 1. Let's use commas since they're much more visible. 3, 5. That's now a row. Now I'm creating another column. Say 7, 9, 5. That's another row. And say 12, 34. Say 51. That's another. So let me. Yeah, we can print out the output so to see how. So you see that is 1, 3, 5. That's a row. 7, 9, 5. Another row. 12, 34, 56. Another row. So now with that we can now go and I can still create another one. Say Q is equals to say 34, 50, something like that, and then how many rows are those? So far 2. So the last one is say 17, 35, 62. I close that, suppress that. Okay, I can now still go on and display if you want to see how Q looks like. Yeah, Q is there, 34, 64, 12. So that's how you create a matrix in Matlab. So next let me just suppress, comment this one out. It's fine, let's leave it. Next, we can now go to matrix operations. Matrix operations. Matrix operations, you can have P plus Q. Let's see what that says. C is equals to that. Let's try displaying C. Hopefully we can add matrices. Yeah, so we can't add matrices. At least I don't think we can. You can add, You can add but element wise, Yeah, you can add but element wise, something like this. Hopefully. Let me see. Yeah, let's start with multiplication. So for multiplication, it would basically be that. Why is this error still? Yeah. So multiplication, that's how you multiply two matrices. Oh, is it correct? Because I thought for multiplication, the order should be reversed for the matrix you're using to multiply it.
Remember, use 3 by 3.
Yeah.
3 by 3.
Oh, 3 by 3, so it is okay. But basically, just pick up the logic, the math, you will figure out everything. So that's basically how you create a matrix and the rest of the applications. Let's say a transpose. How do you transpose a matrix? So I'm going to transpose say P. So for that, I would simply say P and then put that apostrophe. Yeah. So let me say D is equals to that. Display P. Oh, suppose to be D. My bad. So let's go back and see how P looks like.
What does transposing change?
Transposing, whatever was a column now becomes a row. What was a row becomes a column, So hopefully, but that's how you do it. If you can remember where our P is there. So we had 1, 2, 3 as a row. Now here we have 1, 3, 5 as what? As a column. So that's how you do transpose. So next is let's have determinant. So I think matrices and vectors will probably be the simplest topic. So so for determinant, let me just copy this. Let's say V is equals, for determinant I simply say det. Let me get of P. P was our matrix that side. So for the guys online, still you'll do what we've been doing. We still have some 30 minutes before the project is returned, and then we switch to fully online. Yeah. So shall display V. So that's our determinant. Inverse. inverse, you would say, let me say S is equals to INV of P. That's how you do it. What else do you want to know? Trace. Trace is the sum of the elements along the leading diagonal. Yeah, you want to see them, eh? Okay, it's fine. Let me finish trace and then you see it. Let me say E is equals to, so for trace you write out the entire word, trace of P. Okay, so let me add in the display functions. Display E, display S.
I think you'll have to suppress this.
Okay, so it's going to print them in their order. So yeah. So the last one we had was trace. So we're getting the trace of P. And if you remember what P was, let's see, did this display P anywhere? Let's display P down here, so that we can see that it comes out 62. Yeah, so that was our P, the last one. So if you get 1 plus 9 plus 52, it becomes 62, yeah?
Yeah.
So that's how you do trace. So what other matrix operation did you learn yesterday? Determinant, inverse. Yeah. Yeah, so now agent. Let me see. Yeah, we have done cross, we have done that. So next we can now go to agent vectors. Agent values and vectors. And remember, agent values and vectors are only applicable for a square matrix. For a square matrix. A square matrix, hopefully you all know what a square matrix is. So P and, yeah, that's the number of rows and columns are both the same. So both P and Q were square matrices. So in case you want to get, there are two ways of getting agent values and vectors. So I'll show you the first way, agent values. So for agent values, I would say the first method, let me say R is equals to EIG. I put in 2 brackets, P. Yeah. I can come and display R. So those are the agent values of that vector. If you do it manually, you can confirm.
And you decomposition.
Yeah. So those are agent values, eh? But now we want to get the vectors, eh? So for the vectors, I'm going to give you a method that gives you agent values and vectors at the same time, but only that one of them lies along the diagonal, values and vectors. So in a test, you could simply get a question that asks you to get what are the agent values or agent vectors. And you have, say, a 5 by 5 matrix. So if you to do that, okay, I'm not discouraging you using it by hand, but it takes a while. If you had a 2 by 2, 3 by 3, 3 by 3, it would be possible. But once you go to those large matrices, just write in 2 lines of code and you walk away with your vectors and values. So, so to get our values and vectors, I would use a function, say v into d is equals to EIG of p. We shall confirm the values and see if they're the same. So this one here, there's no need to suppress. That's it's a built-in function. So you see, it brings for you, the first ones are the vectors v. These are the agent vectors it will generate for you. And then the next, it brings for you the values. They are the elements that lie along the leading